Good evening, Honors Math Analysis students. This is 2.1, Complex Numbers Continued. I'm going to go ahead and just write as I talk. Quick review. This is my I for imaginary number. It's equal to the square root of -1. I squared is equal to -1. I also would like to review adding and subtracting. So another way that we could do this is just distribute all the negatives, remove all the parentheses, and combine like terms. So 6, it would be 3, it would be 9. Be 3, be -1, that would be 0, and that would be 2. So that's not subtracting or adding, it's adding and subtracting complex numbers. Let's try another one. Again, if that's too confusing, this can be written as, let me expand this. I wrote each one of them in A plus BI form. Just that was a pure imaginary and that was a pure real. But I also don't need to do that. I could just distribute all the negatives and make it combine like terms. I just was looking at this one right up here. I don't need those zeros. So it's a 7, a -3, a +4, a +6, a +8, and a +2. So I have 7, I have 4, and I have 12. I have 10, and everything has to be written in A plus BI form at the end. All right, let us continue. I would like to review one more that we did today in class. Oh, let's see if I can make something up. I might ask you to simplify or divide, whatever it is. I may not have I in the denominator. That is not allowed. The way to get rid of that is to multiply by the conjugate. The conjugate is like the difference of squares. The first number stays the same, the second term stays the same, and the sign in the middle changes. Be like a difference of squares. I can only multiply by 1. I'm going to go back now and put parentheses so I can do this easier. 3 times 3 is 9. Positive 2i and a negative 2i is -4i squared because the middle terms zero out like difference of squares do. I'm going to work on the numerator. 7 times 3 is 21. 7 times a -2i is -14i. -2i times 3 is -6i. -2i times -2i is +4i squared. Now I'm going to continue to clean that up. First off, I know that's a -1, and that's a -1. So I would like to put all the real numbers first in the numerator. That's a 21 and a -4. So it's going to be 17. Now my imaginary term's behind. Now in the denominator, this is a 9. This was a -4, now times a -1. So that is really 9 plus 4, because again, -4 times -1 is a +4. So it's 13. This may not be boxed in. It's not an A plus BI form. I want to see the real part and the imaginary part. All I have to do is give each numerator its own denominator. I look and see if I can simplify those fractions. I cannot. I'm now allowed to box it in. Let's talk about roots of a negative number. So the principal root of a negative number is like so. This is very critical. Whenever I take the square root of a negative number, I cannot do it. You put it in a calculator and it'll say error. So what you're actually doing here, actually the middle step, is I'm allowed to do this. Remember, because it's -1 times a b, right? That's how you get a negative b, -1 times b. I'm allowed to break it up like this, and I already know what the square root of -1 is. It's I. So let me show you how we're going to use this. And again, this is nothing new. You've done all of this last year. The square root of -25 times the square root of -4. I may not do either one of those. Try putting that in a calculator. It'll tell you error. What I must do is I must use this property up here on each one of these so that I can. And the only way I can is if this is 0 or a positive number underneath. So here's what I'm going to do. I'm going to take out that -1, square root of -1 times the square root of 25, square root of -1 times the square root of 4. Well, this is an I, this is 5. This is an I, this is 2. That's 10I squared, -10. I'm sure what some of you wanted to do that is wrong. Try again putting that in a calculator. Cannot. Let's try another problem. Let's try addition. First off, I may not work with either one of these because there's a negative underneath the square root. I must address that first. All I did is extract out the -1, gave it its own square root. I know that is I. Well, now I'm going to try to simplify the square root of 27. That's the square root of 9 times the square root of 3. I'm looking for perfect squares. So for 48, I could do what? 4 times 12? I think I can do something bigger than that. How about 16 times 3? So that's an I, that's a 3, square root of 3. It's an I, that's a 4, that's a square root of 3. I'm going to rewrite that, clean it up just a little bit. That's how we want to write that. Then I look to see if I can actually add these two terms together. The only way I can add up these two terms with square roots is these square roots have to be the same. It's like matching variables. That has to be an x and that has to be an x, identical. So there's 3 of these, there's 4 of these, so there's 7 of these. Let's try another problem. And the reason I'm doing some of these is because this is what your homework's going to look like. This course is not easy. It's got a lot of algebra. So since this has a square, what this means is there's 2 of these and multiply them together. I may not proceed another step because I have a square root with a negative number underneath. I must address that first. All I did is separate that out. Square root of -1, square root of 3. Square root of -1, square root of 3. Now I did was take the square root of -1 and make it I. Now I'm going to go ahead and multiply. So -2 times -2 is 4. -2 times I square root of 3 is -2 I square root of 3. This I square root of 3 times a -2 is -2 I square root of 3. Then I squared of 3 times I squared of 3 is I squared, square root of 3, quantity squared. So I have 4. I have negative 2 and negative 2 of these. These they may combine, so there's negative 4 of them. This, well, let's see, I think I'm going to write it here this time. The I squared is a negative 1. It's being multiplied. The square root of 3 is squared, so that's 3. So let's see, that's a negative 3. That's a positive 4. I get a positive 1. That's my real part. Here comes my imaginary part. And there it is in A plus BI form. I'd like to do another example. Again, I know what's in your homework. Well, I don't want to do too much until I extract out that negative out of the square root. I'm going to go ahead and give the 2 to each one of these because I'm going to have to write it in A plus BI form anyways. Let's see, here comes my I. So let's see, square root of 12 is left in the numerator over 2i. Well, let's see, square root of 12 is really square root of 4 times square root of 3. So that is 2 square root of 3 over 2i. Lots of algebra. Lots of algebra. All right. I needed this last year. Quadratic equations with complex imaginary solutions. Mouthful. Quadratic equations, equations where the x is squared. What kind of solutions? I'm going to get complex solutions. Okay. So I guess I'm going to get a quadratic. It's going to tell me to solve. So I'm supposed to go solve. Well, when I solve, I set that equal to 0. Let's see if I can factor. Nope. So when I cannot factor, I'm going to go ahead and use the quadratic formula. Let's see, so negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Let's see, 4 minus 8. Aha! In this solution, I'm going to get a complex number. I cannot go any further until I address that negative underneath the square root. At the same time, I'm going to get ready for my A plus BI form. I'm going to separate that 2 and put it underneath each one of the numerators. When you solve a quadratic for complex solutions, they always come in pairs. They always come in pairs because of this right here. I'm going to have a negative underneath, which means I'm going to get a complex number, my I, and the plus minus, I'm always going to produce a pair of them. They're going to be a pair of conjugates. If I wanted to write this in solution set, which is how you're going to see it in the back of the book, this is what they look like split up. So now I'm going to go ahead and finish writing down your homework assignment. Let's see here. So you have 29 through 49 odd. This is due Tuesday. You can work on this assignment in class tomorrow on Friday, and also the one that we did today in class, which I started out tonight's video with a little bit of review. Thank you.